Hello, my English is really bad. Could you help me count from 1 to 5? 1, 2, 3, 4, 5. Okay, cool. So you see what you just did there? You started counting from 1 to 5. You started from 1. That's the way you naturally start counting. Natural numbers. You naturally start counting from 1. Think about when you learn a new language. Japanese, ich ni san chi, that's from karate class. Hanadul set net, that's Korean from Taekwondo. I san su, that's from Chinese class. I listed all of these Asian languages, I wonder why. But you see, you naturally start counting from 1, natural numbers. Next, we have whole numbers. What are whole numbers? Whole numbers include all of the natural numbers. What do I mean by include? They also have 1, 2, 3, 4, 5, but they are whole numbers. So they start from 0. 0, 1, 2, 3, 4, 5. Whole numbers, they start with a 0. Whole numbers, they start with a whole. All right, you can stop the video here. The 2 sections I went over should be the beginning for your high school math. But if you want to stay, the next section we have is integers. So integers include all of the whole numbers, 0, 1, 2, 3, 4, 5. But they also include negative numbers, like -1, -2, -3. The symbol that you use to represent an integer, the symbol for it is a Z-looking symbol. So think of your friend Zorro, and he thinks he is so smart because he can count backwards, even past 0. 3, 2, 1, 0. -1, -2, -3. So integers, all of your whole numbers, including negative numbers. Okay, next we have rational and irrational numbers. Let's go over rational numbers first. So rational numbers include all of the integers we just went over. 3, 2, 1, 0, -1, -2, -3. And they also include decimals and fractions. Okay, before we go on, just remember the golden rule of fractions. You can have any number divided by 0, it cannot be done. Any number divided by 0 cannot be math. It's impossible. It cannot exist. This will be a rule that you have for the rest of your life. Any number divided by 0 cannot be done. Just remember that. Don't forget it. All right, back to it. Rational numbers and irrational numbers. You have to tell the difference between the two. But how do you do it? To find a rational number, when you write it in its fraction form, it will be an integer over another integer. Integer over integer. That is rational. Rational number, integer over integer. You can also find a rational number if the decimal value, those are the numbers after the dot, if those numbers are repeating, then the number is also a rational number. To find an irrational number, you will have a non-integer over an integer. Non-integer over integer, irrational. For example, you could have a square root of 2. Square root of 2 is a non-integer over 1, an integer. Square root of 2 over 1, non-integer over integer, it's irrational. All right, let's play a game. Is the number rational or irrational? 13. So first, you got to write it in its fraction form. To do that, if you can't remember fractions, you take the number and put it over 1. Pretty easy. Take the number, 13, put it over 1. 13 over 1. Integer over integer. It's rational. 0.9. 0.9. Write it in its fraction form. That'll be 9 over 10. integer over integer, rational. The square root of 2, that is not a perfect square. So then we'll have square root of 2 over 1 in its fraction form. That is a non-integer over an integer, irrational. Pi is a naturally occurring irrational number. Okay, so the square root of 2 and pi, those are your two. If you see that, that's an automatic irrational number. Minus 61. Minus 61 in its fraction form is minus 61 over 1, integer over integer, rational. Square root of 49. It's a square root over 1, right? No. Square root of 49 is a perfect square, which equals, square root of 49 equals 7. 7 over 1, integer over integer, rational. 7.134625 with a bar above the decimal values. That bar means that the decimal values are recurring or they are repeating. And if the decimal values are repeating, then it is rational. Remember, recurring or repeating decimal values mean that it is a rational number. 6.312 with a dot above the 1 and a dot above the 2. This means that the 1 and 2 are repeating. Repeating numbers, it is rational. The square root of 50, that is not a perfect square. Square root of 50 over 1, non-integer over integer, irrational. Trick question, 5 over 0, rational or irrational? Remember the golden rule, anything over 0 cannot be done, undefined. The world will end. All right, so take everything we just went over, rational, irrational, integers, whole numbers, and natural numbers. Those are all real numbers, rational, irrational, integers, whole numbers, and natural numbers. Those are all real numbers. Put them all one side. Next, we have unreal or imaginary numbers. And there is one quick rule to find an unreal number. If you see a square root and there is a negative number inside, then it is unreal. The square root of any negative number is an unreal number. And that's it. So let's go over everything one more time. Natural numbers, the way you naturally start counting, 1, 2, 3, 4, 5. Whole numbers, they start with a 0. 0, 1, 2, 3, 4, 5. Integers, minus 3, minus 2, minus 1, 0, 1, 2, 3. Rational numbers, these include all of the integers and also decimals and fractions. To find a rational number, if you can write a number in its fraction form and it's an integer over an integer, it's rational. Or if the decimal value of the number is recurring or repeating, then it's rational. To find an irrational number, if you have a non-integer over an integer, then it is irrational. Non-integer over integer, irrational. Square root of 2 over 1, non-integer. And lastly, the square root of a negative number, any number, doesn't matter what it is, that is unreal. And that's it. 100 sums, 10 equations, 20 triangles, and a 1-hour nap. Do it every single day.